Alright, so we're starting with polynomials here. The first thing is just identifying the degree of a polynomial. So that's actually pretty easy. The degree of the polynomial is just identified as the highest power of the variable. If there's two of them, you have to count how many total factors there are of both variables. But in this case, there's only one. So you can go through term by term and identify the degree of each term. So x cubed has degree 3, minus 8x to the fourth has degree 4, 2x has degree 1, 6x to the fifth has degree 5, and 8 has degree 0, if it's just a constant term. But when they ask for the degree of like everything, you just look for the highest one. So here the degree is just 5. So we just enter 5 and that's it. For adding polynomials like this, adding and subtracting, so first thing I would say here is when adding or subtracting polynomials, we can add or subtract the coefficients, which are just the numbers in front, if they are like terms. So that means they have the same variable and same power. So for this number 2 example here, on my screen, what do we have? We have minus 5x cubed plus 10x squared minus 3x plus 10. And then sometimes it's even easier to just line them up vertically because you can just match up all the like terms term by term. And if they are missing one of the terms, you can just put a 0 there as a placeholder. This one, there's no matching, no missing terms, so you don't have to worry about that. So the easiest way to do this is vertically, and then we just add the regular numbers. So we have 10 minus 5, which leaves us with 5x cubed, and then 10 plus 3 is going to be 13x squared, and then we have minus 8x, and then a plus 3. So that would be your final answer there. We can just line everything up, and we're good to go. So we have the 5x cubed plus 13x squared minus 8x plus 3. Any questions there? Pretty straightforward. It's a little, so what's the degree? Again, you just look at the final result, and the highest power available is 3, so that's going to be the degree. Highest power of x. Subtraction is a little bit different. It's just one step more because you essentially have to distribute the negative sign before you can combine everything. So when we're looking at number 3, you may want to take the extra step of just changing it to an addition problem before working on it. So we have this 7x cubed minus 3x squared plus 9x minus 8. And then we have minus, and we have the parentheses, which means we have to distribute that minus sign to each term. So we can change this to an addition problem by switching all the signs and removing the parentheses on the second polynomial. So basically we could have 7x cubed minus 3x squared plus 9x minus 8, and then I can distribute the negative and remove the parentheses down below. So then I would have a minus 10x cubed, and then with the 8x squared, that's two negative signs now, so I would get plus 8x squared plus 9x, and then a minus 3. So everyone see how we changed the signs on each term there to remove the parentheses. So that's the only difference with subtraction. So then we can add those up. We would have minus 3x cubed plus 5x squared plus 18x, and then minus 11. And that would be it for adding the polynomials. So this is probably a little more straightforward than the working with all the radicals last time that you may have encountered. All right. So one extra step there, but nothing too tricky. Again, the degree of this polynomial is 3. And then now we're going to move on to multiplying polynomials. So the trick to multiplying polynomials that I like to say, multiplying polynomials. So a lot of people like to teach polynomials by using FOIL. But the problem with FOIL is it only works when you have a polynomial with 2 terms multiplied with a polynomial by 2 terms, and then your final output is only going to have 4 terms. So this acronym might not be as catchy, but it's basically the rationale behind multiplying polynomials of any size. So here's the acronym, ETOTFTETOTS. That's all you have to remember to multiply polynomials. Really, it's just an expression. So what does this really stand for? To me, this stands for each term of the first times each term of the second. And that's going to work whether or not you have more than 2 terms in one of your polynomials. So this first example that we saw, we have a 2-term polynomial times a 3-term polynomial. So how does that go? Let's see. It was 2x plus 3 times x squared plus 9x plus 2. I can't remember. What did I say? X squared plus 9x plus 2, something like that? Yeah. So our first polynomial here is 2x plus 3. So what has to happen is this 2x needs to get multiplied by every single guy over here. So that's the first term of the first. And then you would multiply the 3 by every single guy in the second polynomial. And then you would combine any like terms that you had. So one of the things that comes into play here is we have to have our rules of exponents when we multiply x's, right? So I actually like to do this kind of on 2 separate lines for each term. That way you can kind of line them up in terms of your like terms, because remember, you're only going to be able to add the numbers in front if the powers of x match. So we start by multiplying 2x by x squared. So how much is 2x by x squared? 2x to what power? Third. Yeah. 2x cubed. So we're adding that power of 1 from the 2x with a power of 2 from the x squared. Then we multiply 2x by the 9x. So that's 18x squared. And then 2x times 2 gives us plus 4x. So then what we can do is we can go the line below and move 1 spot over and start multiplying by our 3's. So we've got 3 by x squared gives 3x squared. And then 3 times the 9x, the middle term, gives 27x. And then 3 times the last term, 2, is a plus 6. So then you can just add vertically. So notice the way I've done it, they all line up in terms of like terms. So you have your pairs of like terms are your 18x squared plus 3x squared and your 4x plus your 27x. So those are the ones that combine to give your final answer here. So that's 2x cubed plus 21x squared plus 31x plus 6. And that's what we would enter for our final answer. So we had 2x cubed plus, what did I say over here? 21x cubed. Sorry, x squared plus 31x plus 6. Any questions there? So that's a general way to do it. Notice FOIL doesn't work just because that second polynomial has 3 terms. So there's, many terms that you could consider as inside terms. So you want to use this more general method. They say to use FOIL here, but again, we can just use the same thing. So this is a short one. Or I wasn't doing an example, I was just saying number 5, that's the faster way. So we want to multiply 2x plus 1 times 6x plus 5. So multiply the 2x across, and you would get 12x squared. 2x times 5 is plus 10x. Then move down and move 1 over, and multiply the 1 through. And multiplying by 1's easy. It just repeats the polynomial. So the only two things that combine are the 10x and the 6x in the middle. So we get a 12x squared plus 16x plus 5. Pretty straightforward. Number 6 is similar. The one thing to keep in mind here is when we multiply the minus 9 through, the minus stays with the 9 as we multiply to both terms. So it's not only going to be minus 9 times 10x, but it's also going to be minus 9 times the 7 in the second row. So for number 6 here, we have 2x minus 9 times 10x plus 7, and we get 20x squared plus 14x, and then here's where the second row, the minus 9 comes in. We do minus 9 times 10x, which is minus 90x, and then minus 9 times 7 is minus 63. So again, just add vertically, and we get 20x squared, and then that should be minus, 76x? Minus 63. Right. So far, so good. Okay, this one is designed to look a little bit trickier because it has an exponent. So there's a little bit of a warning here. Again, when you're trying to multiply 6x plus 5 squared, there's no distributive law for exponents like this. That's actually like a big mistake. So warning. 6x plus 5 quantity squared is not equal to 6x squared plus 5 squared. You can't distribute the exponent like that. What you have to do is you have to multiply it as 6x plus 5 times 6x plus 5, two sets of parentheses, and then multiply the polynomials. So this is a no-no. This actual mistake is so famous and occurs so often, it has a name. It's known as the freshman dream because, I don't know, so many first-year students wish it were true or something. I don't know. There's a Wikipedia page for it, but it's one of the common mistakes. So, but we're not going to make that mistake. We are going to write 6x plus 5 squared first correctly as 6x plus 5 times 6x plus 5, because you have to repeat the factors, and then we're going to go through the process of multiplying. So this would be 6x times 6x is 36x squared, and 6x times 5 is plus 30x, and then jump down and multiply the 5 through. So 5 times 6x is, again, 30x, and 5 times 5 is 25. So we can add and get our final result, 36x squared plus 60x plus 25. That's the final answer there. Okay. X minus 12 squared is going to be the same sort of thing. I think if you actually go to the textbook on these, they will appeal to formulas, but there's no real need for the formulas. I can write them both down for you after we finish this, but you can always just use the ETOTF to ETOTS trick and write everything out that way. So we get x minus 12 times x minus 12. And then this is going to come out. First, x times x is x squared. X times negative 12 is minus 12x. And then here, remember, we're multiplying the minus 12 by both of them. So minus 12 times x is, again, minus 12x. But then your minus 12 times minus 12 is going to leave you at the end with a plus 144. So adding gives us our final answer of x squared minus 24x plus the 144. All right. Okay, so here's one where I'm talking about the degree of polynomials with multiple variables like this. So number 9 here. So when polynomials contain more than one variable, like terms must match both variables and their powers. So for instance, xy is a different term than an x squared y term because the powers of x don't match, even though they do have both letters. So in this one, it's relatively straightforward. I have 6x squared y plus 7xy plus 2, and then I'm just going to write it down below. So the first one is actually a minus. So minus 4x squared y. So notice the x squared y matches, so that's a like term. And then we have a plus 5xy, and then we have a minus 1. So works out very nicely here because all three terms match up perfectly with the other three terms in the first polynomial. So we can just add their numbers. So we get 2x squared y plus 12xy, and then a plus 1. What would you say the degree of this polynomial is? This is a little bit tricky. It's 3, yeah, so it's 3. So clearly the term with the most variables is this first one, this 2x squared y. So basically there's 2 factors of x and 1 factor of y. So there's 3 total variables in that term, 3 factors of variables. So that's what constitutes the degree. So if they ask us for the degree on this polynomial, we would say the degree is 3. So degree is in fact 3. A lot of times, you'll use that rule from one variable where you say, okay, what's the biggest power I see? And you might say, well, x squared is the biggest power I see, so it's just 2. But you have to actually include the factor of y, since that's one single term. Okay, so the degree of the sum, again, the degree is going to be 3. And again, now we have products with multiple variables, but it works the same sort of way. We just need to write this thing out. Maybe I should mention quickly the formulas that they will include in the book. They'll tell you 2 formulas, one for the square of a sum and one for the square of a difference. So sometimes they're useful to note, like, so the formulas for the squares, a plus b squared. If you know the formula, you can kind of just jump to the answer. A squared plus 2ab plus b squared. And then you also have something like a minus b squared, which is a squared minus 2ab plus b squared. So those 2 formulas are sometimes cool. Are useful. They can actually help you with like some arithmetic things if you want. So we talked about squaring numbers that ended in 5 last time. You can actually use these 2 formulas to like figure out larger sums if you want. So like if I were doing 31 squared, I would immediately know that that is 961, right? How did I know that so quickly? Well, I used the formula up above. I said, well, this is 30 plus 1 quantity squared. And 30 times 30 is easy to do, right? That's 900. 2 times 30 times 1 is 60. That's easy to do. And then 1 times 1 is 1. So add those 3 things together. It's 961. So that's kind of cool. Maybe we could also do it with something like 49 squared. So what is 49 squared? Maybe I gave myself one that's too difficult, but we'll see. Probably 2,401, something like that. Let's see if I did it right. I'm thinking of this as 50 minus 1 squared. So that should be 50 times 50, which is 2,500, minus 2 times 50 times 1, so minus 100, and then plus 1, so 2,400. So you can use these things to improve your mental math. It doesn't seem like people focus on mental math anymore, but it's something to do if you can't fall asleep, I suppose. Anyhow, usually for polynomials like this, 4x plus 7y quantity squared, I don't appeal to the formula, I just write it all out. I say 4x plus 7y times 4x plus 7y. And I'm going to get my 16x squared. And then 4x times 7y is going to be plus 28xy. And then my next two, 4x times 7y is plus 28xy. And then 7y times 7y is 49y squared. So I get my final answer below of 16x squared plus 56xy plus 49y squared. And that's that. Okay, so factoring is the process of kind of reversing multiplication. It's trying to take common divisors out and also biggest common powers of the factors of the variable. So the greatest common factor is just looking for the biggest power of x that both of them have, and then also the biggest number that divides both. So if we have 25x squared plus 30x, well, we know we can take an x out because they both have at least one factor of x, right? 25x squared has two factors of x, and 30x has one factor of x. So the most you can take out is one factor of x. That's the most they both have. And then you want to know what's the biggest number that divides both into 25 and 30. Well, that would be 5. So your greatest common factor here would be 5x. So that means we can take out a 5x, and then we would write a set of parentheses. And for each term that you started out with, you need a number that would multiply to the corresponding term, right? So what number do you multiply 5x by to get 25x squared? 5x, yeah, very good. And then you would do the same thing with the 30x. So what number times the 5x gives the 30x? 6. And so that's your factorization. And you can notice that if you multiply or distribute the 5x back through to check, you get exactly what you started with. The reason factoring is going to become important for us is it's going to allow us to solve equations later. So expanding is good, but factoring is nice for helping us solve equations. So we would just enter that here, 5x times 5x plus 6. Okay, and then it doesn't even just have to be a single number that you can factor out. Sometimes it can be an expression that matches. So that's the case here. If we have x times x plus 14 minus 14 times x plus 14, this entire expression of x plus 14 matches in both terms being subtracted. So we can actually factor that out. So if I factor out an x plus 14, and you just take that away from the very first term, that's all that's left over is the x. So inside your parentheses, you would have an x. And then in the second term, if you take away the x plus 14, that's all that's left is the minus 14. So that just factors into x plus 14 times x minus 14, which is pretty convenient. Okay, so now we're going to start to factor things that may not look so obvious, but we can actually combine the ideas that we had from number 11 and number 12 sometimes to get those things to work, even for things where the factors might not appear obvious. So when they say factor by grouping, as they do here in number 13, what they're looking for is they're looking for us to basically take the 4 terms that we have in this polynomial and divide them into 2 different pairs. So I want to think of this as being a pair of numbers and this as being a pair of numbers. And then we're just going to look for the greatest common factor of each part. So the first one, the x cubed minus the 8x squared, there's no number with x cubed, so the only thing we're going to be able to take out is the highest power of x that's common to both, which in this case would be x squared, right? That's the most you can take out from the minus 8x squared. So what I'm going to do is I'm just going to factor that out. And so x squared times x would make x cubed. And then x squared times minus 8 would make minus 8x squared. So that's how the first one would factor. But then we'd still need to factor the second group. Now the second group, 56, doesn't have any x's. So that's all we're looking to take out now are any regular numbers that might divide into both 7 and into 56. So that turns out to be 7. Both of those numbers are divisible by 7. So I can write a plus 7 and then a set of parentheses. And what am I going to get? Well, I'm also going to get x minus 8. 7 times x makes 7x, and 7 times minus 8 makes minus 56. So we did that by pairing and then using greatest common factor. Now, though, if you look, we have the same thing that we did in number 12. We have the common expression x minus 8, and we'll be able to factor that as well. So if you take out an x minus 8, the first x minus 8 is being multiplied by an x squared, so we can put that in a set of parentheses. And the second x minus 8 is being multiplied by a positive 7. So we can write a plus 7 there. And that is the full factorization of number 13. So we've got x minus 8 times x squared plus 7. Okay. So now let's talk about factoring polynomials in general. So factoring quadratics is what I want to talk about. So quadratics basically look like ax squared plus bx plus c, where when you're looking at the problem, a, b, and c are just regular numbers. Okay, so there's kind of the easy case and the hard case. So the easier case is if we just have x squared plus bx plus c. There's no a in front. So that's all we have to do is find two numbers that multiply together that make c, but when you add them together you get b, and that's how it factors. So for instance, to find the factorization, just find two numbers that multiply to c but add up to b. Okay, so let's just do a quick for example. Let's say we have x squared plus 11x plus 30. What are we looking for here? We're looking for two numbers that multiply to 30, but when you try them, they also add up to 11. So that's pretty easy, right? That would be just 6 and 5. 6 times 5 makes 30, but 6 plus 5 makes 11. So that tells us exactly how this factors. X plus 5 times x plus 6. Notice you can always check that by FOILing it out, right? You have your x times your x gives the x squared, and the outside 6x plus the inside 5x gives 11x, and then your two constant terms, 5 times 6 gives 30. So, if we go back to the one here, we've got, so this example is, did I already do the, oh, no I didn't. So number 14, we have x squared minus 15x plus 54. So now we need two numbers that multiply to 54, but they add up to negative 15. So if they add up to a negative, but they multiply to a positive, that means both numbers actually have to be negative. Right? Because the only way to get a positive is a positive times a positive, or a negative times a negative. And if it were a positive times a positive, adding two positives will never give you a negative number. Does that make sense? So, does anybody know the two numbers? Yes. 9 and 6, but they both need to be negative. So if we do minus 6 times minus 9, we would get positive 64. And if you add those two numbers, you would also get negative 15. So that's exactly how this will factor. X minus 6 times x minus 9. Okay, so back to polynomials, we also have a slightly harder case. So we'll call this 2 the harder case. And this is where it looks like ax squared plus bx plus c, and that number in front is not just 1, right? And this one we basically have to do using factoring by grouping. So we have to factor by grouping. At least that's the way I'm going to teach. There's several other methods that I've seen. There's like a tabular method you may have learned where they write stuff down in some sort of 2x2 array. But this way I like because it encapsulates the way that we've done things so far and seems to be the most prevalent. When I learned factoring, I think in high school, they just had us write down two sets of parentheses and try all the options till you figured one out. So at least this is a little more streamlined. Okay, so what do I mean by that? Let's look at an example. Let's say we have, let's say, I don't know. Let's say 3x squared, sorry. Yeah, so I think this will work, minus 10x minus 8. Okay, so we're going to still play that same number game that we did in the easier case, but we have to start by multiplying two numbers. So we actually need to multiply the 3 by the negative 8. So that's negative 24. Right, that's 3 times negative 8. That's where that came from. We had to multiply this first number with this last number here. So then what we want to do is we want to look for two numbers that multiply to negative 24 but add up to negative 10. Okay, so when you have two numbers multiplying to a negative, you know one of them has to be positive and the other one has to be negative. So the numbers that work here are negative 12 and positive 2, right? And that's what we're going to use. We're going to actually replace the minus 10x with negative 12x plus 2x. We need 4 terms to make those two groups of 2 terms, if you remember from example number 12 or 13. So we rewrite this as 3x squared minus 12x plus 2x minus the 8. And at that point, we can group them again like we did in the previous problem, where we just try and take out the greatest common factor. So the greatest common factor of 3x squared and minus 12x is 3x. So we have 3x, and then what would go inside the parentheses? Well, 3x times x would make 3x squared, and 3x times minus 4 would make minus 12x. And then from the second group, the only thing you can take out is the 2. 2 divides both 2 and 7. So if you take out a 2, we have x minus 4. And then we have that common thing inside the set of parentheses. So we can take out the x minus 4, the common binomial expression, and then we'll be just left with 3x plus 2. So that's the harder case where we factor by grouping. If you use a tabular method or another method that you like, that's fine. Let's see what their example is. So for number 15, we have we're using the letter a, 2a squared minus 9a minus 45. So we would start by multiplying 2 times negative 45. We would get negative 90. Then we need two numbers that multiply to negative 90, but when you add them, you get negative 9. So 15 and 6, I think, are going to do the job there. We want minus 15 and a positive 6, so we know that we can write minus 9a as minus 15a plus 6a. That's how we split the middle term to get our two groups. So we have 2a squared minus 15a plus 6a minus 45. And then you cannot take any regular number out. That's all the first group has in common is the a. So if you take out the a, we get 2a minus 15. And then the second group, that's all we can do is take out a 3. And we'll also get 2a minus 15. And then we've finished our factorization. So we'll get the 2a minus 15 times the a plus 3. And that's the factorization for this problem. Any questions there? So a lot of times it's just, getting the hang of the process. So a lot of these, there will be a lot of factoring problems. Yes? Of what? So, yeah, we're going to do this one right here. Yeah. So, yeah, this is the third one in the harder case. Again, the harder case, because it's 4y squared, if it started out with y squared, once you find the two numbers, you're done. If there's a number in front of the y squared, like there is here, that's the harder case where we have to do the factoring by grouping. So we have the 4y squared plus the 15y plus 11. So the first step is to multiply the 4 with the 11. So we have 44. So now we have to try all of the different two numbers that could multiply together to 44 until we find two of them that add up to 15. Pretty straightforward here. It's actually 4 and 11. Those are the numbers that work, right? 4 times 11 is 44, but 4 plus 11 is 15, right? There's not so many possibilities with 44, right? It's either 1 times 44, 2 times 22, or 4 times 11. So 4 and 11, which just means we're taking that middle number and writing it as 4y plus 11y. We're replacing the 15y by that. It's kind of like a clever form of the same expression. So 4y squared plus 4y plus 11y plus 11. And then we just split it up into the first two things that are added together and the second two things that are added together. And we look for the greatest common factor of each one of those. So we want to take out 4y for the first pair. So 4y times y would make 4y squared. The only thing you can take out of 4y to get 4y is 1. 4y times 1 gives 4y. And then from the second group, they both have 11. So you can take out 11, and you're just going to be left with y plus 1. So your y plus 1 is now your common thing in parentheses. So we can take that y plus 1 out, and you're just left with the numbers in front, which are the 4y and the plus 11. And that's how we get the factorization. So once you get those numbers, each one of these is basically a 3-step problem. All right. Okay, so this one's quite a large polynomial. And not all polynomials will have a factorization. That's what they mean when they say the trinomial is prime. So if you have something that doesn't factor, it's prime. And basically, if you look at the numbers and you can't find such numbers that exist, then that means it's a prime polynomial. I'm not sure on this one. I just know that the factors are going to be quite large. So let's see. So on one where the numbers are large, you may want to just use a calculator. But let's see. The same process will work. I should probably write down the problem first. So we have 35x squared minus 103x plus 72. So what we would do is we would multiply 35 times 72. So let's go ahead and do that. Appealing to the calculator. So that's 35 times 72 is 2520. At least that's divisible by 10, right? That makes it kind of easy to find some numbers that factor into it. Now it's a positive number, so that means the two factors that multiply to it both need to be negative. And it looks like this one is probably going to be a prime polynomial, just because if both numbers have to be negative, I mean, we could do the prime factorization of 2520, which would give us all the possible candidates for the summation to the negative number in the middle. But I don't know. So yeah, maybe we should do the prime factorization. So 35 and 72. 35 is 7 times 5. 72 is 8 times 9, let's say. And 8 is 2 to the third, and 9 is 3 squared. So we know this number is really 2 cubed times 3 squared times 5 times 7. That's the prime factorization. Usually they don't come out this complicated, but let's see. I'm just trying all the possibilities. So 8 times 5 would be 40. So there you go. So I kind of grouped these together and then grouped these together, right? Because 8 times 5 is 40, and 9 times 7 is 63. And so then basically the numbers that are going to work, 2520, we're going to want to do negative 40 times negative 63. So if you multiply those two numbers together, you get 2520. And if you add negative 40 and negative 63, you get negative 103. So this is tremendously complicated in terms of the arithmetic. Numbers this large are typically not chosen. So like, you can't really churn through them in your head. So one of the ways is you just kind of get your calculator and you go through, and it takes a little bit of time is all it does. But the process is still essentially the same. So now that we have those numbers, we can go back through the actual grouping, right? So we have our 35x squared, and we want to subtract 40x, and then we want to subtract 63x, and then we want to add 72. So 35x squared and 40x, you can take out a 5x from each of those. So if you take out 5x, we're left with 7x minus 8. And then 63 and 72 are both divisible by 9. But if we took out 9 as is, we would get minus 7x plus 8. And we want it to be 7x minus 8 so it matches. So what we want to do is we just want to take out a minus 9 instead. So let's factor out a minus 9, and then we'll actually get 7x minus 8. And so then we get 5x minus 9 times 7x minus 8. And that's our factorization. So back to, let's make this smaller. So quite a tricky problem there. But we cracked it. Check out the battery here. Okay, so now difference of squares. This is a way to factor things that have two terms, and it just relies on the fact that we have the formula. So this is known as the difference of squares formula. It says if you have something that looks like a squared minus b squared, it can factor into a plus b times a minus b. Right, because your outside minus ab will cancel with your inside plus ab. So if you ever have two things that look like this, 9x squared minus 16, you might notice that 9x squared is really 3x times 3x, so it's 3x squared, and 16 is the same as 4 squared, right? So this can be factored as 3x plus 4 times 3x minus 4. So if you recognize these squares there, then you can find lots of factorizations. Okay, again, another difference of squares problem. So 25x squared minus 121y squared. So you might recognize that 25x squared is really 5x times 5x. So it's 5x squared. And 121y squared is just going to be 11y times 11y. So this would factor into 5x plus 11y times 5x minus 11y. So you just need to recognize those. And if you can't tell if it's a perfect square, what can you check on your calculator? You can just use the square root button, right? You can say, okay, well, what's the square root of 121? If it comes out nice, you know it's a perfect square. Okay, this one says factor the perfect square trinomial. They appeal to a formula, but we don't need to. We can just use the regular method that we've been dealing with so far. So they're using z squared plus 38z plus 361. So again, this is the easy case. We just need to look at that last number, 361, and you need to find two numbers that multiply to 361 but add up to 38. So it turns out that that's just 19 times 19. 19 times 19 makes 361. You could use that trick from earlier, right? It would be 20 squared minus 40 plus 1. So this just factors into z plus 19 times z plus 19. But since they both match, we can just abbreviate that, right? Because it's the same repeated factor, z plus 19, repeated 2 times. So it's z plus 19 squared like that. Again, they're probably appealing to that a plus b squared formula, but a plus b quantity squared, but we can just stick to the normal method and it's going to work. I'm slightly curious, do you think that it'll accept my answer if I do z plus 19 times z plus 19? Curious. What do you think? Yeah, no. I don't know. Sometimes it'll say, although your answer is correct, it's not in the form that we want, and then make you do it again. Yeah, it took it though. So All right. So again, this is another perfect square, but why don't we end here and we can do that one starting off next time. So that's it for the Module 2 homework for this week, and we'll do the rest next week. So let me see if I can